Now we're going to deal with what are called piecewise functions. Piecewise functions are functions that are in pieces, right? If we look at this graph right here, we can see there's this piece, there's this piece, there's this piece. They're pieces of graphs, and we can plug things in, we can graph them, we can write the equations. We're going to do all these things. So the first thing we want to know how to do is evaluate the function at a point. What that means is, what is the value when x is -3? A value is the output. The output is the y value at that particular x value. So in order to find these numbers, we're going to have to go to the x and then go to the y. Let me show you what I mean. So for example, in part A, we have f of -3. F of -3, well, that's this x value, but that's not the answer. We have to go down to the graph itself. And then this point where it touches -3 and then whatever, this y value, that's the output. So the answer is -7. And it's that simple. If we're finding f of -2, well, -2 is right here. So we're going to come down to the graph, that point right there, wherever it intersects, -2, that y value, that's the answer. So the answer is -4, because that's the y value right there. Another one, -1. -1 is right here. So we're going to come down. Oh, wait, that's an open circle. If it's an open circle, we've got to go, oh, that's another open circle. So really at -1, we're going to come up here to that point right there. So that point right there, that's the answer now. So that point is the point -1. And my pointer is not pointing. -1. Oops, and I lied. It's not -1. It's this y value here, which is 3. Now we're going to f of 0, that's right here, so we're going to come down to the graph because it wasn't above anymore, it's down here, so it's at -6. And then finally f of 1, that's right here, so we're going to come down to the graph again, and we get down to -8. So it's just a matter of finding the y value that goes with that x value on the graph, wherever that graph happens to be. Then we also need to be able to evaluate algebraically. So if we're not given a graph, how do we do this? It's very simple. You take the number and you plug it into the appropriate location in the equation. So what's appropriate? Well, we determine what's appropriate by looking at what this number is. So, -3 here. -3 is the number we're dealing with. So we need to look here, here, and here and see, where does -3 fall? Well, -3 is not between -1 and 2. -3 is not equal to -1. It's in between -5 and -1. That means we're plugging it into that part of the equation, that piece. So we're going to have 2 times -3 plus 8. It doesn't always go in that part of the equation, but for this one it does. So it's -6 plus 8. We're just doing math now, which equals 2. So your answer is 2. That was for the -3. Now let's look at -1, right? Because that's part B. Well, where do we see -1? We see a -1 here and here. But for this one, it's equal to -1, so that's how we know it's going to be that answer. And we go to the equation. The equation is just -6. There's not an x value there. If there's not an x value there, there's nowhere to plug in -1. The answer is very simply -6. So we just write -6. Another one. Now we have the number 1. 1 is not equal to -1, so that would not be applicable. 1 is not in between -5 and -1. 1 is in between -1 and 2. So we're going to take 1, we're going to plug it in right there. So we have 1 plus 5, which is 6. 2, hey look, is also in that interval, right? It's from -1 to 2. So we have 2 plus 5, which is 7. Right? And it's okay if you use the same equation multiple times. It's just a matter of finding which one to use when. The last thing we're going to have to do is graph. I know you love to graph equations, especially when they're linear. I do want to point out really quickly, if a line is flat, the equation is y equals a number. If it has a slope, the equation is y equals mx plus b. So, and m is the rise over run, b is the y-intercept. So let's do that. Okay. So the first thing we're going to do is figure out, where are these lines? Okay, and when I say that, I mean we're going to write the domain. If you notice, when we looked up here, it was -5. Here, let me erase that. We got -5, -1. equals -1, -1 to 2. So that we have to include that piece of our piecewise equation in order to accurately write the equation that goes with this problem. So if we look right here, we have two pieces. We have this piece and we have this piece. So let me color code it for you. So we're going to draw a little bracket. We're going to have two pieces. So let's just look at the red one first, this left side. This left side starts at -4 and ends at 3. The way we write this is -4 less than x less than 3. That's all you do. Then we look at whether or not the points are open or closed. Remember, if it's open, it's not or equal to, but if it's closed, like this one right here, you know, a little line right there because it's closed. All right, that's our left equation. We'll have now we have to write the equation that goes with it. So this is a line, it's not flat. So we're going to have y equals mx plus b. And again, m is the slope, b is the y-intercept. So let's start with m. What's the slope? If I start here and I go up, up, over, up, up, over, up, up, over, up, up, over. Remember, you always read these graphs from left to right. So the rise is 2, the run is 1. So that'd be 2 over 1. So that means our equation is 2x plus our y-intercept. Well, our y-intercept is right there. So it's -1. So it's actually going to be 2x minus 1. And that's it. You wrote that piece. That was the equation. Actually, I'm going to put that in black. Okay. Now we're going to do this piece right here. So starting number starts when x is 3, ends when x is 6. So we're going to have 3 less than x less than 6. If it starts somewhere and ends somewhere, you're always going to have less than symbols every single time. At 3, it's open, so there's nowhere equal to. At 6, it's closed, so there's a line. Now we find the slope. To get from one point to the next, we go up 2 over 1, 2, 3. So that is 2 over 3. It's positive. Positive. 2 over 3. So that's 2/3 x. Now if we look, hey, this doesn't actually cross the y-axis. So how do I know what my y-intercept is? Well, you take that slope and you pretend it's going the other way. So if it's up 2 over 3, it's also down to left 3. So that line would continue right there. So it would end at +3. And that's your piecewise function. Just to make sure you're 100% or maybe 70 at least, let's do another problem. So in part B, we have this piece and we have this piece. So that's how I'm going to split them up, left side, right side. I'm going to do my little bracket. Boop, 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 boop. And I'm going to have a comma, because the left side is going to be the equation, the right side is going to be the domain for that equation. Now, I do want to point out for part B, it doesn't have a start and an end point. It has an arrow here. See that arrow? That means that we're going to have x for both, and this side has an arrow too. So we'll have x and then a number, and it's just going to be one number because it's going to be going to the left or to the right as necessary. So because this is going to the left, we're going to have a less than. Because the green one is going to the right, we're going to have a greater than. And we're just going to put that starting number, which in this case is -5, and in the other case is -1. Now we're going to write the equation. Remember this, the red line is flat. It's perfectly flat. So we just put the y value there, which was 5. So it's just 5, and you're done. Horizontal lines are the easiest. For your other line, we have a slope. So we're going to go down 1, 2, 3, 4, 5 over 1. So that is down 5 over 1. So that translates to -5 over 1, which is -5x. Then we're looking at the y-intercept again. The y-intercept here is 4, so it's -5x plus 4, and we're done. Fairly painless.